Rogue comets are the ghosts of the galaxy, drifting alone, bound to nothing, belonging to no star. They move in silence through the dark spaces between solar systems, untouched for billions of years, carrying secrets older than the sun itself. And now, for the first time in human history, the James Webb Space Telescope is preparing to hunt them. Most people think of comets as harmless balls of ice that loop around the sun. But rogue comets are different. They aren't part of our solar system. They don't follow predictable orbits. They don't play by the rules. They drift through interstellar space like cosmic castaways, shaped by conditions Earth has never seen. And each one could carry new chemistry, new physics, and even the building blocks of life from a star system we'll never visit. For decades, astronomers didn't even know these things existed. They were too faint, too distant, too cold to detect. But after Oumuamua arrived in 2017 and Borisov in 2019, and now 3I Atlas approaching its 2025 close pass, scientists realized something shocking. Interstellar objects aren't rare. They're everywhere. The galaxy might be full of rogue comets passing silently by, just out of sight. The problem is, older telescopes couldn't see them. They were too dim, too small, too fast. We only detected them when they were already inside the solar system, when the sun lit them up for a few weeks before they vanished again into the void. But the James Webb Space Telescope changes everything. Webb was not designed to hunt rogue comets, but it turns out it might be the perfect instrument for the job. And what it could discover may force us to rethink how solar systems form, how life spreads, and how much of the universe we've been blind to all along. Rogue comets are made of frozen materials that glow faintly in infrared wavelengths. Webb is the most powerful infrared telescope ever built. Even the coldest objects leak heat, and Webb can see that heat across billions of kilometers. Suddenly, things that were invisible become visible. Comets drifting between stars become detectable. Tiny interstellar fragments reveal themselves in the faintest whispers of infrared light. Webb won't just spot these objects. It can analyze them, break their light into spectra, identify the molecules frozen inside them: water, methane, ammonia, complex organics, even compounds that don't exist in our solar system at all. This is what excites scientists more than anything. Webb can turn rogue comets into messages from alien star systems. Every comet that drifts into our reach carries a chemical signature of the place it came from, the temperature of that system, its radiation environment, the types of stars nearby, the variety of planets it once orbited. These comets are snapshots of alien creation, cosmic postcards drifting through the galaxy. And now, Webb can read them. But the real reason astronomers are preparing this hunt is far more dramatic. Rogue comets might not be just carriers of alien chemistry. They might be carriers of alien life. The theory isn't new. Panspermia, the idea that life spreads between star systems on comets and rocks, has existed for nearly a century. But for the first time, we have the tools to test it. If Webb detects certain organic patterns, or amino acid ratios, or unusual isotopes in multiple rogue comets, it could suggest that the building blocks of life aren't unique to Earth. They're universal. They travel. They spread. Maybe life is not the exception in the universe, but the rule. Imagine discovering that the seeds of biology on Earth originally drifted here on a rogue comet billions of years ago. Imagine learning that every solar system in the galaxy is exchanging chemical materials through these icy messengers. That planets are not isolated. They are connected through comets acting as nature's delivery system. But that is only one part of the mystery. Rogue comets don't just travel between stars. Some of them are huge, tens or even hundreds of kilometers across. Too big to be fragments, too stable to be debris. Where did they come from? Some theories suggest they are survivors of ancient planetary collisions. Others believe they were ejected from young star systems by gravitational chaos. A few scientists whisper a more provocative idea. Some rogue comets might be leftovers from stars that died billions of years ago. Relics of solar systems erased from the galaxy long before Earth existed. If Webb can study these objects, it might help reconstruct the history of stars that no longer shine, using comets as their last surviving fossils. And then there's the biggest question of all. How many rogue comets are out there? The answer could reshape our understanding of how the galaxy works. Some simulations predict trillions of them. More rogue comets drifting between stars than planets orbiting them. A cosmic ocean of frozen travelers filling the spaces between solar systems. If that's true, the Milky Way is not empty between its stars, it's crowded, filled with ancient objects carrying secrets we've never seen. But detecting them requires a telescope powerful enough to pick up the faintest warmth from the coldest object, the smallest glow from the darkest ice. That's why astronomers believe Webb is our first real chance at surveying interstellar space properly. Its instruments can detect objects thousands of times darker than anything Hubble could see. It can spot subtle outgassing events, the tiny whispers of vapor escaping a comet's frozen surface. It can reveal objects that don't reflect sunlight at all. This is crucial because most rogue comets are invisible to optical telescopes. They don't shine, they don't reflect, and they don't reveal themselves until they're extremely close. But in infrared, even absolute darkness leaks information. A comet 10 trillion kilometers away emits a faint heat signature, and Webb can see it. That's the breakthrough. If Webb successfully detects rogue comets, it will also help solve a lingering mystery. Why are some interstellar objects so strange? Oumuamua accelerated without explanation. Borisov looked more pristine than any comet in our solar system. 3I Atlas behaves like a hybrid between a comet and something else entirely. Were these just random outliers? Or are they examples of a larger population of exotic objects drifting in interstellar space? Webb could answer that. If it finds dozens, maybe hundreds, of rogue comets with strange chemistry or odd shapes or unusual motion, it means our understanding of space is far too narrow. It means the universe is producing objects we've never theorized about. One idea gaining support is that rogue comets from other star systems may contain ices not found here. Supercold nitrogen glaciers, exotic carbon chains, molecular compounds formed in extreme environments we can't simulate. If Webb sees these chemical fingerprints, it would rewrite astrophysics overnight. Suddenly, the diversity of planetary systems becomes far wider than we ever imagined. But the biggest game changer might come from something far more subtle: tracking their motion. If Webb can observe multiple rogue comets over time, it could measure tiny shifts in their trajectories. Those shifts could reveal gravitational forces acting on them. And those forces might expose something astronomers have been searching for decades: the structure of dark matter in our region of the galaxy. Dark matter doesn't interact with light, but it pulls on objects through gravity. Rogue comets drifting freely through space could trace this hidden cosmic skeleton. They could act like breadcrumbs, revealing the contours of dark matter filaments stretching across the Milky Way. If Webb can detect enough rogue comets, they could become tools, natural probes for mapping the invisible structure of the galaxy. And that would change everything. Because for the first time, we wouldn't just be observing dark matter indirectly. We'd be watching it sculpt the paths of real objects, real travelers, real cosmic wanderers. But maybe the most thrilling part of this upcoming hunt is what it means for the future of exploration. If rogue comets are as common as scientists suspect, then they aren't just mysteries. They are opportunities. They are potential destinations, potential samples, potential stepping stones for missions decades from now. Imagine a future probe launched not toward a planet, but toward a rogue comet entering our solar system, a true visitor from another star. Imagine drilling into its ice, extracting material formed around a sun that burned billions of miles away. Imagine holding in your gloved hands a sample from an alien world. Webb's hunt is the first step toward that future. By cataloging rogue comets, we are building a map, a catalog of interstellar visitors we can study, intercept, maybe even land on. Each comet becomes a chance to understand the galaxy in a way we never could from Earth. And who knows what might be waiting inside? Biology, chemistry we've never seen, clues to the origin of life, evidence of processes happening in distant star systems, or something even stranger, something that doesn't fit into any category we've created yet? Rogue comets are messages written in ice. Ancient, mysterious, alien. The James Webb Space Telescope is finally ready to read them.